All right, so here are the class examples 2 through 5 in lesson number 4, sorry, lesson 5. And what we're going to try and do here is just to solve this thing out. And we want to prove this thing. So I just separate my left side and my right side. Sine x cos squared x plus sine cubed x. And my right side is just 1 over cosecant x. Now I'm going to take out a sine x to start. Why am I taking out that sine x? Because I see it. And that's part of the problem with these, is that if you don't see where you're going with it, it can be a real struggle to figure out where to go next. Now, once I've done this, now I should be immediately getting a little bit of a thrill, because this cos squared plus sine x, there's my hammer. So I hit that with my hammer, bang, that becomes 1. So I get sine x times 1. Now, if I really wanted to, I could write that sine x as 1 over cosecant x. And there we go. Left side equals right side. And I am. This one here, I usually start with the more complicated side. So I'm going to start with this. So I'm going to turn everything into sines and coses. Now note that 1 plus cos A. That's going to be an important feature later on. I'm going to deal with the numerator though first. So this is going to be sine A cos A plus sine A all over cos A all over 1 plus cos of A. And now I'm starting to see some things happening. And I'm going to just deal with the numerator in green. So I'm going to factor out a sine A from my numerator. And what I'm going to have left is cos A plus 1 all over cos A. And then I'm going to have my denominator, which is this 1 plus cos A over 1. And instead of having it written as a fraction of one thing over the other, I'm going to multiply by the reciprocal of my denominator. And there's where I can start canceling things. So this 1 plus cos A and that 1 plus cos A cancel out. So now I have sine A over cos A, which equals tan A, which equals 1 over cotan A. And voila, left side equals right side, and I'm feeling good. I'm on a roll. Non-permissible values of my identity are going to happen when cotan A equals 0 and cosine of A equal -1. Those are my two denominators. This cosine A is -1 is going to happen when A equals pi, right? If I think about -1 right there in my unit circle. And cotan A is 0. Cotan is the inverse of tan, or is x over y, and x over y will be 0 there at pi halves and 3 pi halves. All right, one last one for me to do algebraically. I'll let you guys take a look through the non-permissible values and things later. I want to prove this thing. Secant squared x, secant squared minus 1 equals cosecant squared x. What I'm going to start with is by turning everything into sines and coses. So secant squared is 1 over cos. And now I'm going to get common denominators here. So this is 1 over cos squared x, and all over 1 minus cos squared x over cos squared x. And then this is going to become 1 over cos squared x times, if I do the reciprocal of my denominator, 1 minus cos squared x. Cos squared x and cos squared x cancel off. And then because cos squared plus sine squared equals 1, I can say sine squared equals 1 minus cos squared. So this becomes 1 over sine squared, which is the same as cosecant squared of x. Ba-bam. So that's the way those work. Try them out. Practice, practice, practice. Come with questions when you have them.